So we've looked at dealing with natural logs and with e, the exponential function. You need to know as well, though, the basic shape of their graphs. So the first one, y equals e to the x. You need to know that it crosses at 0, 1, and we can see, hopefully, that the x-axis is your asymptote. And then y equals ln x. It goes through 1, 0, and the y-axis is your asymptote. So what you need to be able to do then with these graphs is you need to be able to transform them. So these graphs follow the normal rules for transforming graphs that you did months ago. And the important ones, depending on the graph, you need to show either where the point 0, 1 or 1, 0 moves to or transforms to, and you need to show where the asymptote is. Okay, so they would be the important things to mark on your new graphs. We'll start with the exponential graphs. So sketch the following graphs. First one, y equals e to the power of minus x. So I've changed the x into a minus x, and that means it's a reflection in the y-axis. So that means it still goes through 0, 1, that stays the same, and actually the asymptote will also stay the same. So you can see from the graph, the green graph here is y equals e to the power of x, so a transform graph that we'll have to draw, y equals e to the power of minus x, is in red. Second one then, y equals e to the power of x plus 2. So we've changed x to x plus 2, so we know that's a translation. Just change the x's, so it's either going to go left or right. We're adding plus 2, so we know we're going 2 to the left, and we're not going any up or down. So that means our point 0, 1 moves to minus 2, 1, and our asymptote will just stay the same. Okay, so we can see our original graph would be y equals e to the x, and our transform graph, we're moving it 2 over, so it goes through the point minus 2, 1. Our third one then, y equals e to the x minus 3. So we're subtracting 3 from the whole equation, so that's a translation, and we know it's going to go up or down. It's minus 3, so it's going to go down, so it will go none to the left or right, and down 3. So that means that the point 0, 1 moves down to 0, minus 2, and it also means the asymptote will move. So it's going to move down to y equals minus 3. It'll move down from the y-axis down to the x-axis down to y equals minus 3. So you can see our original graph is in green again, y equals e to the x, and it's going through the point there at 1. That point moves down 3, so it's going down through minus 2. And you can see that this at minus 3 is your asymptote. And our fourth one then, y equals 2 e to the x. So we've multiplied the whole equation by 2. So that's a stretch by 2, by a factor 2 in the y direction. So our point 0, 1 will move to 0, 2, but your asymptote will just stay the same. So again, our green graph is your y equals e to the x. So our red graph, it's stretched up to 0, 2. And it just comes up steeper than the other one, and our asymptote is still going towards the x-axis. Moving on to the ln graphs then. So sketch the following: y equals minus ln x. So it's a minus in front of the whole equation, so that means a reflection in the x-axis. It'll still go through 1, 0, and your asymptote will stay the same. So again, our original graph is the green one. That's y equals ln x. So it's going through there at the point 1, 0, and we've reflected this round. So the asymptote, instead of going to the negative y-axis, it will go to the positive y-axis, and that's your y equals minus ln x. The second one then, y equals ln of x minus 1. So we've changed the x to x minus 1, so we know that's a translation. We know it's going to go left or right. So this one here, it's a minus 1, so it's going to go to the right. So a translation of 1, 0. So the point 1, 0 will move over 1, so it will go over to 2, 0, which means the asymptote will move as well. And it will move to the line x equal 1. So again, our original graph is the green one, ln x. The red one is moved over to point 2 there. So that's y equals ln of x minus 1. And you can see with the green, the asymptote is to the y-axis, and now it's going to move to this line here, which is x equal 1. And one more then, y equals ln of 4x. So we can either say that's a stretch of a factor a quarter in the x direction, or if you prefer to say it's a compression by a factor 4 in the x direction, that's fine, they're the same thing. Okay, so the point 1, 0 will go to 0.25 0, but our asymptote will stay exactly the same. Again, our green graph is y equals ln x. You can see go through there at 1, and ln 4x here. That's going through at quarter in there, but you can see they're both going to the same asymptote.